Fellow coders, gather around the warm glow of the CRT. Welcome back to the command line. So, you've mastered the basics, right? Well, today, we're plugging in the Simon's Basic cartridge. And trust me, this is where we leave those simple programs in the dust and start building some really powerful structured applications. We're going to go from apprentice to architect. Ready? Okay, let's dive in. First things first, let's talk about the enemy. Every single one of us who started with Standard Basic knows this beast all too well, spaghetti code. You know what I'm talking about, a tangled mess of go-to and go-sub statements that just jump all over the program. After a few dozen lines, trying to follow the logic is like trying to untangle a cassette tape with a pencil. It's an absolute nightmare to read and even worse to debug.
But this is where our power-up comes in. Simon's Basic was the toolkit that let us think like professional programmers. It gives us the commands to build code not as some tangled web, but as a set of clean, logical building blocks. It is absolutely time to level up.
And here is our mission briefing for today's session. This is our level map. We've got two main paths to explore. First, we are going to upgrade our loops and logic, mastering commands that give us way more control. Then we'll tackle procedures, the real key to truly modular, reusable code. Our mission? To transform our programming skills from basic to structured.
Okay, let's start with a logic upgrade. We're going to tackle one of the biggest limitations of the standard if-then statement. So this slide right here shows how we solve a really common headache. In Standard Basic, if b equals 1, then print correct, only handles the true case. If the condition is false, the program just keeps on going, forcing you to add a messy go-to to handle the wrong answer. Ugh. But Simon's Basic introduces else, giving you a clean plan B. It's just like a light switch. If is the on position and else is the off position, all in one simple, super readable line. So what happens when your brilliant logic statement is too long for the C64's 80-character line limit? Well, you hit a brick wall. And that's where RCOMP comes in. Think of it as a special kind of extension cord. It tells the very next line of code, hey, we're still talking about that last if statement. It passes the true or false status down, letting you build these complex, multi-line logic blocks without breaking the rules. Okay, logic circuits upgraded. Now let's move on and see how this builds into mastering loops. We all know and love for next, but Simon's Basic gives us looping structures with so much more flexibility and power. On the screen, you can see our two new heavy hitters for loops, repeat until and loop exit if. Now, they might look kind of similar at first glance, but their core philosophy is completely different. The key is when the program actually checks the exit condition. Let's break down repeat until. See how the condition check is at the very bottom of the flowchart? This means the code inside the loop is absolutely guaranteed to run at least once. It's a do first, ask questions later kind of loop. This is perfect for something like a password prompt, right? You have to show the prompt at least once before you can even check if the input is correct. Now for the ultimate in flexibility, we've got loop exit if. Loop on its own creates an infinite loop. I mean, it will just run forever. The magic is exit if. This is your escape hatch, and the beautiful part is you can place it anywhere you want inside the loop, at the start, in the middle, or at the end. This gives you incredibly precise control over when and why your loop terminates. All right, this is the big one. This is the quantum leap from hobbyist to, well, programmer. We are going to eliminate spaghetti code forever by embracing the awesome power of procedures. So what is a procedure? It's simply a block of code that you give a name. You just wrap it between PROC and end PRC. So instead of go sub 1000, you can now have a procedure called PROC get user data. Your code instantly becomes self-documenting. You know exactly what that block of code is supposed to do just by reading its name. No more hunting for line numbers. So how do we actually run these procedures? With the XEC command. You should think of XEC as the modern replacement for GoSub. I like to call it the polite boomerang. Your main program throws it, it goes out to the procedure, does all the work that's defined in there, and then it reliably comes right back to the very next line of code. It's predictable, it's clean, and it keeps your main program flow so simple. But what if you don't want to come back? Well, that's where call comes in. This is the structured replacement for goto. It's a one-way ticket, a warp pipe. It sends the program to a procedure, and that is it. It's perfect for jumping to a main menu or some error handling routine. But here is a critical warning. Because it doesn't return, you must not have an end proc in a procedure that you call. If you do, the program tries to return to nowhere and crash.
You know, theory is great, but let's see how these new tools actually forge the engine of a real program. And just as importantly, why this structured approach was an absolute necessity on a machine like the C64.
Just look at this. This is the skeleton of our program. The main logic, right there in lines 20 through 40, now reads like plain English. First, execute input data. Second, execute sort data. Third, execute print data. All the complexity, all the messy calculations are neatly tucked away inside their own named procedures. Anyone can understand the purpose of this program just at a glance.
So why did this structured approach matter so much? Well, it all comes down to this number, 38,911. That's how many bytes of free memory we had for our programs, 38 kilobytes. In that world, code efficiency wasn't just a preference, it was a law of survival. Every single byte counted.
And this is exactly how procedures help us survive. If you have a task you need to do 5 times, writing it out 5 times in linear code just eats up memory. But if you write it once as a procedure and execute it 5 times, you save a huge amount of precious RAM. This write once, use everywhere principle was absolutely critical for creating anything complex on the C64.
Let's just peek inside one of those engine parts, the sort data procedure. This uses a classic algorithm called a bubble sort. The logic is actually really simple. It just looks at 2 numbers side by side. If the one on the left is bigger than the one on the right, they swap places. The program just repeats this over and over, and eventually, the larger numbers bubble their way to the end of the list, leaving everything perfectly sorted.
You've made it. You now have the fundamental tools for writing clean, powerful, and efficient code on the Commodore 64. So let's do a quick flyby recap just to lock it all in.
Here's your cheat sheet. Else gives your if statement a plan B. RCOMP smashes right through that 80-character wall. Repeat until checks the condition at the end. Loop exit if gives you an escape hatch anywhere you need it. Proc puts a name on your code. Exec is the boomerang that always comes back. And call is the one-way ticket. These are the building blocks of modern programming, right here on your C64.
So, what's next? With these tools, you're not just writing lines of code anymore, you're designing systems. You can build menus, complex game logic, data processors that are actually easy to read and expand. The only question left is, what are you going to build with these new powers?
For now, our system is halted, but the skills you've learned today, structured logic and powerful loops, are the very foundation you're going to need for our next session. Because next time, we're taking these abstract concepts and using them to put pixels on the screen and make some noise with the SID chip. Get ready for Level 4, Graphics and Sound. Class dismissed.